everybody, Mr. Mack here. Thought we would take a look at a couple from the challenge set here. So I'm going to skip number 1 and 2 for now. Number 2 is actually a proof that we need to see some material from 4.5 to do. So I might do that later. So let's take a look at number 3 here. And I have some givens here without any proof statement. So the proof is just going to be prove 2 triangles congruent. Okay, prove 2 overlapping triangles congruent. And just kind of writing in short. So we can see here that we have this angle, and I'll just put a hash on it, is congruent to this one. And we also see, let's pull this over here, also see that we've got these doubles here. So this is the same as a double. So so look at the red here. I've got this angle here, and then on the blue for this side, this angle here. So there's one of the triangles we're going to try to pull out and redraw. So it looks like this. And we've got U, V, X. And so the other one that's overlapping is this triangle here. And this is U, V, Y. So we said that this angle, got the wrong one here. This angle is congruent to this one. Here are the little ones right here. And then we've got angle U right here and V. So I've got the given statement, and so the given statement is that those angle pairs that we just discussed. Copy. Right there. And this is given. So see, we've got angle, angle right now. So how can we get either another side or another angle? Well, we're not going to be able to get X and Y. There's just nothing indicating that. But look right here. They both share a side. They both share UV. So my next line here, line 2, I could just say UV is congruent to UV. And when we do that, we say something is congruent to itself, we can use the reflexive property. Property of congruence. Alright? And so now we've got 2 triangles here. UXV is congruent to triangle UXV VYU Y. Angle side angle. Okay, not too bad. Hardest part is just being able to see the triangles and pull them apart, I think. Alright, here's another one. Given this stuff, so we've got a this pair of segments here. We got that. We've got some perpendicular stuff going on here. Alright, so this is given. AX and AY. AX, so it's this segment right here, is congruent to this one. And we get some right angles and stuff. So look at this right here. We got this triangle right here in purple. So let's redraw that one. I think this is much easier to see than the previous one. A, X, C. I kind of didn't draw it very well. Let me redo that. Let me get a straight edge here. Okay, and then the other one is going to be AYB. It goes like AYB. It's like that. So we got A, X, C, and A, Y, AYB. Okay, what do we know? We got AX is congruent to AY, and we know these are right angles because they're perpendicular. Okay, so they share something here. Look right here. What do these two triangles share? They share angle A. So that means we can say angle A is congruent to itself. If you ever see that two triangles share a side or an angle, we can use the reflexive property to show that they are congruent. Now we've got angle, side, angle. I mean, we could say, I guess in number 3, we could say angle X is congruent to angle Y, and just say all, oh my goodness, come on, right, all 90-degree angles are congruent. But I think that's a little superfluous, it's a little extra. So let's write our statement. A, or BYA, BYA, don't forget your triangle symbol in front, is congruent to CXA, triangle, CXA, and Y, ASA. Okay, that's it. I'm just going to do those two and I'm going to post it. Alright, so